My name is Jason Britt, and I'll be presenting clustering potential phishing websites using DeepMD5. Can everybody hear me? Good enough? So, okay. It seems like everybody's pretty familiar so far with phishing sites and phishing kits, but I'll go over a brief overview of the two. Phishing websites, of course, are websites that are spoofing different organizations, often financial institutions, social networking. In this case, we have two instances of a PayPal phish, or two different PayPal phish. These also often consist of many different files. It takes some skill and talent and a sometimes considerable amount of time to actually implement a decent-looking phish that at least somewhat replicates the organization's website that you're trying to phish. So in this case, we can see that there are actually 41 support files or local domain files used to generate the phish with the Superman kit on the front, and 22 files used for the credit card image there. So these phish, even though they are attacking or trying to spoof the same organization and look somewhat similar, make use of vastly different support files. So what we're going to do is we're going to look and try to generate support file signatures. And that's how we're going to try to attack this problem of grouping these phishing websites. We can see in this region's phish that one of the files is actually the region's image at the top that's incorporated. Some of the other images or other files used are other image files like the submit and roll and the image at the bottom of the page for equal housing lender. Some of the other files that are often used are script files, and as you can see, I've got no script up here, and it's blocking several files that should have executed. To kind of, after this brief overview of phish and phish kits, well, sorry, I didn't mention phish kits. Often, since creating a decent phishing website that tries to imitate, at least at some superficial level, actual organization's website, takes some time and some skill. Not everybody can do this. So not every person that can go out and download an attack tool can create a phishing kit. So what ends up happening is we'll actually have phishing kit authors, people that will go out, spend the time and energy, that have the technical expertise to create these sites. They'll then package those up into what we call phish kits and then go through and whether it be forums or email lists of people he knows, distribute these different phishing kits, often backdooring them with his own drop email address. So as soon as these things are distributed out and set up, he'll get a copy as well, but he won't tell the people he's distributing that phishing kit to that he's actually doing that. So to kind of place this whole talk in the context of the goal we're trying to achieve, the strategy we're trying to use to achieve it, and then the specific actions we're taking or tactics we're taking to implement that strategy, which would be this talk. The goal we're trying to achieve is make a dent in the phishing population. And the way we're going to try to achieve that is to remove the most prevalent actors. And not everybody that's pushing the button to say, okay, search vulnerability, found the web server, okay, exploit, okay, post the phishing kit and deploy the phishing website. We're not after those people. We want the people that really represent the more the capital, the more scarce resource, the people that have the expertise to create these phish kits. So what we're trying to do is identify and highlight the most prevalent actors that are actually creating these phish kits and hopefully motivate the stakeholders, the institutions that are phishing, and law enforcement to go after these very prevalent actors. So in the related work, we've seen people that try to identify phish for various reasons, of blocking toolbars or blocking email that would often advertise the phish. They'll do this by looking at the incoming email that might advertise the phish, the URL that is actually advertised in the text message, instant message, email, whatever it may come from, or content-based techniques that either look at images on the website or any kind of source code components or a mix thereof. There has been some other research in trying to do actually this phish clustering by actor. Most of that's been based on domains and IP blocks, which can be avoided using fast flux networks or breaking into or compromising web servers. So this technique is more of a content-based kind of attack of trying to identify phish generated using the same phish kit or phish kit family that most likely have the same author. And we're going to do this by looking at the structure or support files that the individual phish use. So I'm going to start off, go over briefly the data set that we looked at, the overview of the technique we used, then a little bit of information and background on the DeepMD5 technique, which is the comparison method we use to generate a score or distance metric that we then use the clustering algorithm to actually, once we've got that distance metric, group these phishing websites into similar groups, clusters. Then I'm going to talk about associating the fish kits to them. We wanted to see, hey, how well does this thing work? Do we actually get clusters of fish where we get fish kits associating to those, where we don't have multiple fish kits crossing into many different phishing clusters, which would indicate that our clustering algorithm is not really doing that great of a job. I'll then go into the results, talking about branding fish kits that actually associated to it, and give an example analysis of a couple of fish clusters and how fish kits associated with them, and then some of the limitations and kind of a wrap-up conclusion section. So first off, we pulled data from January 2011 to almost all of May, made it till May 25th. And we divided this large data set up into 5 different monthly windows. We had too many fish to run this clustering technique efficiently, where it actually complete in a decent amount of time if we ran it over all 5 months. So we diced it up into 5 different pieces to run this over. The URLs that we looked at came from various number of places, many different feeds. Most of them were financial institution feeds, but we also have some security companies and private companies. But majority of fish that we receive, or potential phishing websites that we're notified about that we investigate, are going to be financial institution phishing websites. We had 265,000 approximately potential phishing websites that we looked at. Out of these, we were able to either manually or automatically confirm 38% using various techniques. And our volunteer group that actually goes in and sits in a lab and thumbs through these pages one at a time. We had 12% that we were able to confirm were non-fish. There were 20% that we were just not able to get to because our volume is so large. And we had 30% that were unreachable. These most likely occurred because they were at one-time fish, but by the time we were able to receive the data from the various feeds and process it and take a look at it, they were already down. In this 265,000 potential fish, we were able to identify 349 different organizations that were spoofed or had phishing as sites trying to imitate them. General overview of the algorithms we used. We had a 2 kind of phased approach. Phase 1 was a main page clustering where we'd hash the main index page of the site we were directed to. We would then group these sites based on sites that had the same hash. This was essentially to try to eliminate duplicates. We wanted to try to reduce the number of sites that would go into this more expensive phase 2 clustering. The second phase, we would look at these unique now phishing websites, and we would generate a comparison score using the DeepMD5 technique, which I'll talk about in a second. DeepMD5 technique, we used a minimum threshold of actually greater than or equal to 0.8. So we had to have a connection between 2 phishing websites given by the DeepMD5 score of greater than 0.8. Otherwise, we considered these 2 phishing websites not linked. Once we had our links, we would then apply this link clustering algorithm, which is a well-known clustering algorithm, to generate our different clusters of phishing websites. So a little bit of background on the DeepMD5 technique. Essentially what we're going to do here is we're going to pull all of the different support files that I talked about before that make up a phishing website. We're going to look at and hash those different files. That then just essentially gives us a set of files that make up or support that phishing website. We're going to do this for every single fish and then start comparing the number of hashes that exactly match between these 2 different file sets. That's going to give us an overlap. Then, because the counts between the 2 different phishing sites can differ, we're going to average the 2 different counts by saying an overlap over count 1 of fish 1, overlap of the overlap between the 2 fish over the count 2, and then take an average of those to give us a kind of reasonable weight between the 2 different file sets links. So for example, we have website X, it's got 5 different support files. We have website Y, which has 4 different support files. Between these 2, we have A and B that match, so both A and B have the exact same hash in those 2 file sets. So we got a count 1 of 5, count 2 of 4, an overlap of 2. When we look at 2/5 and average that with 1/2, we get a score of 0.45. So in this case, we would not generate a connection between those 2 phishing websites using that 0.8 threshold. Once we generated all these different points and all these different points or nodes, if you want to think about it that way in this link clustering kind of idea, and the edges between these different nodes, we want to actually run and see what of these different nodes group together. We use this link clustering algorithm, which is kind of, if you want to think about an easy way to conceptualize this, it's more of a graph theoretic algorithm. What we're going to do is pretend the phishing sites are nodes, the DeepMD5 scores are edges, and then we're going to take out all the edges that have low scores, and then look and choose at random any of the individual nodes and see what other nodes we can reach. Any nodes we can reach are then going to be considered a connected component, which is then going to be considered a cluster. So for example, let's say in that middle blob, we happen to pick out a particular point there. We see that all these points are within that 0.8 minimum threshold. We then go and look at each of those. From each of those, we can reach all the other points in that center blob. When we try to cross out of that center blob, we generate a score here. Oh, it's only 0.76. That's not quite enough to meet our minimum threshold. So we have no more nodes we can connect to, i.e. we've got one connected component here. We're finished and we've actually created a cluster. We'll do the same thing over here, go grab another random point, see what other nodes we can reach. We'll have then a new cluster and repeat until we have no more points left. So that's essentially how the clustering mechanism works, and that DeepMD5 score works to give us the ability to apply this clustering. The other thing we want to do is we want to try to associate fish kits to the individual phishing websites and see how this kind of pans out with how a fish kit will relate to the fish and how that ends up when we start grouping fish together into fish clusters. To do this, we couldn't use that DeepMD5 Klashinsky 2 score. We had to use a new score. Often the phishing kits have many files that you can't see from the website. So there could be background PHP files or something else that are only server-side that you can't see. When you grab the fish kit, you get those, but when you look at the phishing website and download all the support files, you can't see them. So what we do is we essentially say, hey, we're going to look for an overlap, just like we did with the DeepMD5 score. But this time, we're only going to take the phishing sites count into account in the score. So essentially what we're looking for is we're seeing how much of a particular fish is a subset of a fish kit. Once again, I got a simple example. Fish site has 3 files that are web-facing. Fish kit actually has 7, I believe, if I'm getting it right. And we see that, hey, we've got an overlap of 3. We're only using the count of the phishing sites file, so we have a Simpson score of 1. Once again, we'll use a minimum threshold here of 0.8. So going into the results, after we ran all this, what did we get? Well, I'm going to go over some of the results with respect to brand, with respect to how phishing kits associated to our different fish and phishing clusters, and then give you a quick example analysis that will hopefully give some kind of concrete examples of some of the numbers I'm going to throw up on the screen. So to start off with brands, we generated 185,000 approximately clusters, with only 265 potential phishing websites, with not all of those actually being phishing websites. That wasn't too great. So we had 22,000 approximately, or 23,000 approximately, multi-member clusters. So those are the ones we wanted to focus on. That singleton clusters wouldn't really give us any advantage. If we have one a particular phishing actor only producing a single phishing website that we can identify, it's not very good to focus on those and go after those. We want to go after the multi-member fish out there, the guys that are producing a whole lot of those. Out of those 23,000 approximately in multi-member clusters, we only had ground truth for about 14,000 of those. So those are the ones we used in our analysis. When we start looking at the 14,000 we had ground truth for with respect to brand, you could see that almost all of them, when we looked at the individual cluster members within a cluster, had the exact same brand label. And that's reflected in our homogeneity scores of 99% plus. So there were only actually 7 sites, or 7 fish clusters, multi-member fish clusters, for which we had ground truth, where there were multiple brands contained within one cluster. So that we felt great about. But once you start looking at that completeness score, what that was reflecting is that we have multiple fish clusters where where the fish cluster has the same label as another fish cluster. So we wanted to look at that, and that motivated us to kind of start looking at the possibility that this isn't grouping by brand, which turned us on to the idea that we're actually grouping by fish kit. So before we go on to looking at the fish kit association, I wanted to dive into the 7 multi-brand clusters or cross-branded clusters. This is a sample of 3 of the members of the largest multi-brand cluster that we had, and there were actually 3 labels in there. I'm sure you can guess from seeing the logos up there that the 3 labels were MasterCard, KeyBank, and Bank of America. So if you start taking a look just on the surface at these 3 different fish that are targeting different organizations, you can see they're essentially the same. The only difference is some slight differences in some of the wording on the main HTML page and the logos at the top. So let's break in and start looking at the phishing kits. With phishing kits, we had about 28,000 fish kits that we tried to relate to our potential phishing website clusters. We had to limit the number of phishing website clusters we threw into this just to limit the number of, or the computational runtime of this. We got down to where we only evaluated the top 24 potential fish clusters. Out of those, we had approximately 8,500 fish kits that associated to 11 phishing clusters. When we examined those, we looked and saw that there were only 6 phishing kits that related to more than one fish cluster, which indicated that we might be actually accomplishing our goal. Although, since we only had 11 phishing clusters that we evaluated this way, that only gives us limited assurance that we were able to do that. So let's break into a specific example. Here I've sampled 6 different phishing websites. Fish 1, 2, and 3, which I believe are on your right, are from a phishing cluster that is attacking a particular financial institution. Fish 4, 5, and 6 are from another phishing cluster that's attacking the same financial institution. In the center there, we can see that we have small image files, GIF files particularly, that are common in between these. These are what we call kind of innocuous common files. On the far sides, we could see that those are the files that these individual fish have in common, but fish 1, 2, and 3 have in common, and fish 4, 5, and 6 have in common, but all of them do not have in common. A particular note is on fish 1, we could see that at the top there's an HTML file, a relatively small one of 307 bytes. Fish 2 and 3 do not have that HTML file. They only have little variations on the PHP files, which will come up in this next slide. So when we start looking and associating the fish kits, I've pulled 4 sample fish kits that we related to fishes 1 through 6. We could see that fish 4 had all of fish 4, 5, and 6 files contained within, hence that Simpson coefficient score of 1. When we start looking at fish kits 1, 2, and 3, we see that fish kit 3 only had part of the file, or a subset of the files of fish 2 and 3, and fish kit 2 had the same. When we fish kit 3 relates to fish 1, we can see it doesn't meet that minimum threshold, so we're missing something there. Fish kit 2 ends up with the same relationships as fish kit 3. When we look at fish kit 1, this is where it gets interesting. We have the same subsets of files in fish kit 1, but when we compare it to fish 1, it's got an even higher score than fish kit 2 and 3. Well, as I was saying when we were looking at that last graph, you notice the little HTML file that was an addition. That's the difference. And when we start looking at some of the path names, we see that there's a particular hacker name in the path. And in particular in Fishkit 1, there's also the tag of update. That's because the update was an HTML redirector file that was essentially just a little add-on. So what we can try to conclude from this is, at least reasonably, using this technique groups fish into clusters where they're highly homogeneous based on brand. These clusters, when we associate fish kits to them, fish kits will only associate usually to one fish cluster. And given that example analysis that I went through, we could say with some reasonableness that this technique will group phishing websites by fish kit family. And hopefully we can motivate the interested stakeholders to go after these particular actors and try to bring down the number of fish out there, or at least make a dent in the phishing population. Some limitations real quick. Innocuous files, so you saw the center files. If we have a bunch of those, the comparison technique doesn't work quite as well. It has a diluting effect. Small file count websites are also a problem. And this technique doesn't group by based on similar look and feel, it does by structure. So while structure would inherently gives a similar look and feel does not mean it has the same structure. Future work would consist of trying to improve our ability to associate small file counts and get rid of these innocuous files. We have a method called syntactical fingerprinting that we hope to investigate further in the future. We'd also like to get more assurances that our clusters, our fish clusters, are actually fish clusters of fish kit families. To do this, we would like to group our phishing websites. That way we can narrow down the number of points we have to look at, and we can evaluate evaluate one group compared to another group instead of all the individual members, which should lower that computational complexity in our runtime. I'd like to give special thanks to my advisor, Dr. Sprague, the head of the department in the security department, Gary Warner, one of my co-authors, Brad Wardman, who I like greatly, and the UAB fishing operation team for putting in so many hours to identify all these fish manually. Thank you.
Hi, thanks for the talk. I have two questions.
Okay.
In your opinion, why there were so many singleton clusters? You didn't have enough, or you didn't have all of them, and that's why they didn't cluster together, or maybe there is a different reason?
With the singleton clusters, I don't believe it's because of our sampling. I think we had enough data points to cover. Mm-hmm. The problem is going back to some of the limitations, those innocuous files. That would cause a problem with divergent innocuous files. Also with very small file counts. Let's say somebody doesn't use local domain files, mm-hmm. and they're referencing, let's say, all of Regions banks. images and scripts. Well, then we only get one local domain file, which might happen to be the main page, which has dynamic content. Hence, we have a different hash. And
all right, yeah, good technique to go ahead and hide yourself behind.
right.
Yeah. Right, and if you go, it's just a curiosity question. If you go all the way to probably the second slide,
I'm sorry, I couldn't hear
if you go to about the second slide on your presentation, it's about the number of samples you had and the number of samples you were able to reach and the ones that were unreachable. Do you have, right, exactly, 265, 611, all the percentages. Do you have any kind of information on the distribution of which companies' phishing sites were still, available, which ones were unreachable? And,
if there was an organization that was being spoofed difference or a particular feed difference.
Right. So, for example, we know PayPal. I work for PayPal. I work with Brad Wardman, actually, for that matter. Probably could ask him questions, but he's not here. So I just wanted to gauge the effectiveness of our takedown process, right? If you look at all the PayPal phishing sites there, would you see a chunk of them, or would it be true to say that 38% of PayPal phish were reachable there, and 30% of them were unreachable, or was it that PayPal phishing sites were mostly clustered in the unreachable, which would be the ideal for me,
right,
and all that kind of stuff. So
we didn't do any particular analysis on this data set with respect to particular organization sites being up longer than others. That has been looked at, I believe, in the past, and actually I think Gary Warner has looked at that. But I didn't put any of that in this. We hadn't done that particular analysis on this.
That's cool. Thank you.
Welcome.
Thank you for your talk. To me, it seems more natural to use the DOM structure in order to generate these signatures rather than the file itself, because, if an attacker knows you're doing MD5, then I'll just add some garbage code or some comments just to, circumvent this. So did you sanitize the file? Did you do some?
Sadly, when we implemented this code, it was a rather fast prototyping process, and we didn't actually normalize the files by taking out and lowercasing everything and removing white space. We're actually in the process of upgrading the phishing system and recoding all of our stuff, everything from the fetching process to the database side of things, and trying to improve the efficiency. And normalizing is one thing we're looking at. But you're right, we could still have the problem of them inserting even if we took out comments, various innocuous HTML references that have no bearing on the look of the page. And that actually is what the syntactical fingerprinting technique that we're going to implement next is hoping to resolve. We're actually just looking at the main page, and I'm sorry I had to fly through that so fast, and dicing that up based on the DOM. And we're going to look at particular objects we feel might be more indicative or might help us identify fish better, such as like script objects, maybe the title, different tables, table elements, things like that. So yeah, that's exactly one of the problems we ran into.
Thank you.
Yeah, I just want to ask a very high-level question. Do you think this phishing will be a problem in 10 years from now?
Not maybe to the same widespread effect it is today. I don't know. As we've seen, like phishing and the botnets have narrowed down to where it's much smaller botnets. I think phishing's kind of going to the same way, and we're going to see more spear phishing attacks. Less of this broad-based, hey, I've got 100,000 emails, I'm going to hit all of them with this generalized kind of format email. It's going to be more of, hey, I've got emails of 10 VIPs in this company, let's format something and get into them. So I think it's going to change. I think it'll still be there. It's just too easy of a social engineering attack to not be useful.